Hello, the topic of this project is indexing and searching distributed data with Solr. And the goal of the project is to demonstrate how the data stored in Hadoop distributed file system can be indexed and searched via Solr. To run this project, I want you to go through the steps of basically taking the local setup of the Solr on Tomcat on Windows and evolving that setup into a truly distributed indexing on CentOS VM and using as input data from the HDFS file system. Let's start first with the installation and configuration of the Solr server on Tomcat. To do that, first you need to download the Solr 421 or whatever version is the latest one, and unzip it into your directory of choice. Then you need to create a new directory for Solr home, something like Solr_home, and then copy an example server from the distribution directory into your new Solr home. You also need to download the latest Tomcat and zip it into whatever directory you want, and that directory will be referred to as Catalina home going forward. Then you need to deploy the Solr War application, web application into the Solr server. To do that, you just need to copy the Solr 421 War into the Tomcat's web apps directory. Just make sure that you rename it into the Solr.war and remove the versioning from the war name. Then you need to do some additional configuration for Solr. In particular, you need to modify the Solr config.xml and adjust all the library paths there, put your own installation directory. You also need to specify the data directory where Solr will be storing the indexes that it will be creating and all the configuration for the local server. On my setup, I have this Solr home directory here, and as a data directory, I just decided to use a subdirectory under the Solr home. Then you need to also provide an additional configuration for Tomcat. This is a solr.conf file that you need to create, and you have to place it into the Catalina's localhost directory. This is the content of the file. You just need to adjust it for the location of your solr.war file. Once you do all that, you are able to start Tomcat and Solr on your local system. You start Tomcat using the Catalina home bin startup.page file, and you can then verify that the Solr is running by accessing the Solr admin console. So this is the admin console. It basically provides information about the server that you are currently running, and the information about the data directory, index directory, and a lot of other stuff. That's also where you can then do searches when you have some data indexed. Right now we don't have the data indexed yet. So let's look at the data that we are going to use for this project. I decided to use the movie ratings data from the Group Plans project. And out of all the different data sets that they have there, I decided to use just three. The user u.data, which is the actual ratings data, u.user, which is the data about the users, and u.item, which is the data about the movies that were indexed. As you can see, each file has lines that are delimited, that have delimited fields, and each field is basically some attribute of the data set. And they can be cross-referenced via the ID. So you can see that, for example, the user ID and item ID. And movie ID is actually the same as the item ID in the ratings dataset. So the next thing that you need to do is to decide how you are going to design the schema for your Solr server, because that's one of the most important steps, because depending on how you design your schema for Solr, you will expose some fields and you will do indexing based on those fields and then searching based on those fields as well. So we will now look at the data, and you can see that the data contains the IDs. However, those IDs are not really unique across the data sets, and Solr requires you to have unique IDs across all the data sets. To do that, what I decided is to append the name of the data set as part of the unique ID. And also for the ratings dataset, you need to also add both user ID and item ID to uniquely identify the line and the corresponding document in Solr. Then the other thing that you need to consider is how you're going to join those data sets later on. Solr has a limitation that you can only join the two data sets, not more. If you want to join more, then there are other ways to do that, and we'll talk about that later. And in order to join the data sets, you actually have to have different names for the fields that you're going to be joining with. It is not as in SQL where you just have the same ID and the foreign key into a table. So because of that, I had to rename some of the fields. And for example, for the user number, I had to use the user number underscore U for the user data set, and item number underscore I for the item data set. So once you make all those decisions, then you update your schema.xml file in the Solr home server directory, and this is the final schema that I have. And then we are ready to start developing the Solr indexer. And Solr indexer is, in this case, is just a simple Java class that connects to the Solr server via HTTP by using the HTTP Solr server class provided by Solr. You only need to specify the URL where your Solr application is deployed. In this case, it's the Tomcats localhost 8080 Solr. And then it's pretty straightforward. The Solr is based on Lucene, so you just need to create a document for each line, and you need to add fields per each item in that line. And then you can add that document for indexing to Solr. And that's pretty much what this code is doing. So once the code is developed, you can then run it. One thing that you also need to do is make sure that you add all the Solr libraries to the class path of your project as you're using them. So once you do that and you run the indexer, then the data become available in Solr and you can start exploring it. So one of the things that I wanted to try is to try joining the data sets. So I wanted to, for example, ask a question. For all movies of type action, find me how many ratings I have of 1 star, of 2 star, and so forth. So basically I wanted to group the ratings for the action movies by rating value. To do that, first you need to create the join query, pretty much. This is what it is. This is a local join between item to data sets, and I specify the filter as action equal 1, meaning that that's a movie action. And then you specify the grouping based on the field rating, and you specify how you want to sort. So once you run this query, and this is where I have this query right now, you can specify all those filters, joins, and grouping parameters right in the Solr admin screen, admin page. You can run the query here, and you get the result. And you will see, for example, that ratings 2 stars for the action movies were given 3,254 times. Rating 3 is 7,000 times, and so forth. So the data looks fine. And now we are ready to move to the CentOS VM and repeat this setup over there. It's pretty similar on the CentOS. You also need to download the Tomcat distributable. You need to download Solr and get your data, of course. One thing that is different, you do need to set up the Catalina home environment variable, and you can do it in your user's .bash profile. And Catalina home is the location of your Tomcat installation. You also need to modify the Tomcat's port from the default port 8080 to something else, because Cloudera's Hadoop distribution, it already uses port 8080 for something else. So you just need to modify the server.xml of your Tomcat server and just set this port to something else. Then you need to do exactly the same setup as you did before. So now everything is set up, and you can start the Tomcat. You can access Solr using the new URL, and it is pretty much the same. You can then get the same Solr indexer code, compile it, and execute it on the CentOS VM. So for that, I just created some convenience scripts which set the class path, including the Solr libraries on the class path, and they compile and run the class. And after that, the data is indexed, and you can do the searches in the Solr on the Solr server. So as an example, I just ran a query finding all the students, all the users of this occupation student, and group them by the zip code. So you can see that, for example, for the zip code 01002, there was only one user. So now we are ready to do the distributed indexer. And what that is, we need to develop a MapReduce job that would basically be taking data from the HDFS system, getting the data line by line, and creating a Solr document for each line, parsing the data the same way as it was done in the local server, and submitting them to the local Solr server for, as an index. So I did develop that in Eclipse, and to do on my Windows machine, and you have to remember to add all the Hadoop libraries to the class path as well. So one design decision that I made was to develop separate indexers for each dataset, because datasets have different formats, different items, different unique IDs, so and it is hard to identify in the mapper which dataset the line comes from. So I decided to just use the separate indexers as you see here. Another thing is that all the work that mapper has to do really is just create a Solr document and index it. So there is no need for some output. So that's why I just use the null writable as the output type for the mapper. And correspondingly, there is no need for the reducer as well. So I just set the number of reduced tasks to 0. And then another thing is that you need to initialize the connection to the Solr server somewhere, and then do the commit after all the documents are indexed. So for that, I used the infrastructure callback methods that are already available for Hadoop jobs. It's a setup and cleanup, and did all that initialization and final commit over there. So once the code is ready, we can package it. And I did that right on the CentOS VM, where I just created the jar and included all the Solr libraries into the actual MapReduce job so that they would be available to the code. And I just created a simple script that was packaging everything into the job jar file. Then I moved the data into the HDFS, and we are ready to run the jobs. So basically, you have to run 3 jobs to index all the 3 data sets. And because I have 3 different indexers, I had to run them 3 times for 3 different indexes. The output of the job, as you would expect, is just empty because you don't have any output from the MapReduce job. And once all those jobs ran, then you can again go to the Solr server on your CentOS and run exactly the same query, finding the groupings of the ratings for the action movies. If you run the query there, then you will see that the results are exactly the same. You will see that you have for the rating 1, you will have how many? You will have 1546 ratings, and you have the 3254 for the 2-star ratings for the action movies, which is exactly what you had on the local Windows server. So at this point, what we did, we indexed the data from the HDFS system, and we were able to search it in Solr. This approach has some serious limitations. First of all, you notice that we can only join 2 data sets. So one way to deal with that is to denormalize the data. And that's one technique where you would just basically duplicate the data and create one large document where you would have all the fields. Another way to do that is to have multiple indexes for different data sets and put them on different Solr servers or cores. That is what the Solr Cloud is about. Another limitation that we have is that the data that we used is distributed in HDFS. However, the Solr index is not, and that is something that you would definitely want to do. And Solr server itself is only a single node server. So all those limitations are addressed actually by the Solr Cloud project, which seems to be designed just for that purpose. So that would be the logical next step to go to. And another thing is that the data input and indexing right now is quite simple. Every time you add data into HDFS, you would have to run the indexers and index the data and add to Solr. So it would be nice if you could somehow automate that. And I think that some of the projects that might be helpful, for example, would be Flume or Hadoop streaming, which do deal with the data streaming and the data batching, job batching. And completely different approach to the distributed search is the Cloudera's Impala project, which is also very interesting. So that would also be something to consider when wanting to do a real distributed search. That concludes my presentation.